Hello and thank you for listening. This project is called Beyond the Stop, a proprioceptive brace for knee hyperextension. We explore how a wearable system can help users become aware of a harmful knee hyperextension during walking, not only by restricting motion, but by supporting motor learning through sensing and feedback. The problem: knee hyperextension is often subtle and difficult to notice during daily movement. Over time, repeated hyperextension can cause pain, instability, and joint damage. Traditional braces restrict motion, but they do not help users understand or learn to control the deviation. Core insight: the challenge is not only mechanical, but perceptual. If users cannot sense when they exceed a safe range, correction becomes inconsistent. So instead of only blocking motion, we treat the brace as a tool that makes movement perceivable and supports learning. System concept: the system combines sensing, feedback, and optional mechanical support. It uses two IMU sensors on the thigh and shank with an ESP32 connected to a mobile app. We support two modes: informational mode with feedback only, and hybrid mode with feedback plus mechanical support. Motion tracking: we estimate knee motion using relative orientation between the thigh and shank. After calibration, the system computes a real-time knee angle. Hyperextension is detected when the angle exceeds a defined threshold. Reliable sensing is critical so users can trust the feedback. Feedback design: we use severity-graded auditory feedback that is dynamically triggered based on joint behavior. At the first level, when the knee enters the early risk zone, a mild cue is delivered to build proprioceptive awareness. If the deviation becomes more pronounced or sustained over time, the system escalates to a stronger signal to prompt active correction. At high-risk levels or during rapid hyperextension, an urgent alert is triggered as a safety mechanism. Importantly, feedback is not based on angle alone, but also on duration and repetition, enabling adaptive and context-aware responses. This allows users to react in real time without relying on visual attention. Motor learning loop: the system follows a sensor-mediated learning loop. Movement is sensed, translated into feedback, and then reviewed after the session. Over time, users learn to associate the feedback with their movement and improve control. Feedback fading and impact: we apply feedback fading. Initially, feedback is strong and frequent. As performance improves, feedback is gradually reduced. The goal is to shift from external guidance to internal awareness and control. The next short video shows the prototype in action, demonstrating real-time knee tracking and feedback. Beyond the Stop is not only a brace, it is a wearable learning system designed to help users sense and regulate knee motion more independently. Thank you.